Hi, this is Mr. McGovern. This is the sixth video in the Balanced Forces series. Where we're going to look at calculations with our force diagram. So there's two different ones we're going to look at, a very simple one-dimensional calculation and then a calculation for a ramp. So let's just say we've got a box here sitting on the ground. It has a mass of 10 kg and I want to find the normal force of that box. So what I can calculate is the gravity force. I've got a formula for that, which is just mass times the gravitational field strength. So mass of 10 kgs times 9.8 newtons for every kg gives me 98 newtons. Now I know the normal force, and according to my force diagram, it's the same size as the gravity force. So therefore my normal force is also 98 newtons as well. That's a very simple calculation. Okay, so now we've got a cat which is sitting still on a 30-degree roof. Find the normal force on the cat. Alright, so the first thing we need to do is, after we've drawn our force diagram, draw our vector addition diagram. Then we need to, we set a triangle, we need to identify all the angles in this. So where does the 90 degree go? Well, it goes between the normal force and the friction force, because the normal force is always normal, 90 degrees to the surface, and the friction is always parallel to the surface. So friction and normal force are 90 degrees to each other. And you can see on that diagram on the left that between the normal and the friction I've put my 90 degree. Where does the 30 degree go? Well, what I'm going to do is go back to the force diagram, and I'm going to move my gravity up. It goes in the left there. Why does it go there? See how I've just moved this gravity up there? Just shifted it around to show you where the angles are. I'm going to shift the bottom of the ramp up as well. So there's the 30 degree from the bottom of the ramp just to my force diagram. And so you can see that the 30 degrees is between horizontal and that friction. You can also see between that horizontal green line and gravity is 90 degrees. So therefore, if I've already got 30 of it, between the gravity and the friction is 60 degrees. And therefore, I also know between friction and normal is 90. I've got 60 of that, so that must be 30 in there. So between normal and gravity is 30 degrees. And if you go back on the left-hand side to my triangle, my vector addition diagram, you can see I've got between normal and gravity 30 degrees. So I've got all my angles. Let's do some calculations. The only calculation you can do to start something like this, again, is the force of gravity is mass times the gravitational field strength. That's the only formula we have. Put your numbers in. It's a 10 kg cat. We still get 98 newtons. So now I know one side of my triangle. I also know an angle in my triangle. It's time to start doing some trig to find out the missing sides of my triangle. So whenever I do trig, I label all sides of the triangle. So that's opposite the angle, because the angle is the 30 degrees. Adjacent to the angle, and the hypotenuse is always the longest side. If it's not clear where that is, hypotenuse is always opposite the 90 degrees. I've got my hypotenuse, 98 newtons, and I want to find the normal force. That's what the question's asking me. So I've got my hypotenuse and adjacent. I always have to write down the little rhyme so katoa, because I'll forget it otherwise. Adjacent and hypotenuse goes with ka, which is cos. So cos 30 is adjacent over hypotenuse, which is the normal force over 98 newtons. Rearrange that to find the normal force, and you get 84.8 newtons for that one. Usually this is a merit, maybe even an excellence question for something like this. So, summary. Draw your first force diagrams before you start any calculations. Okay, and using that, draw a vector addition diagram. So if it's a difficult one, you end up with some sort of triangle. The easiest thing to calculate is the force of gravity. And then from that, you can use SOHCAHTOA if you need to, and trigonometry to find any other sides that are remaining.